The trials represented one of the most ambitious attempts to quantify fighter performance during the entire war. Engineers calibrated instruments meticulously, ground crews balanced propellers and adjusted fuel mixtures, and pilots followed strict protocols to guarantee that the only variable was the aircraft itself. This careful methodology gave the RAF a true understanding of speed limitations, engine strengths, aerodynamic weaknesses, and operational ceilings. It was not uncommon for test pilots to discover that real performance differed greatly from manufacturer claims or frontline assumptions. Historical aviation researchers still rely on AFDU reports because they provide some of the clearest data on World War II fighter technology. These documents remain an essential reference in military aviation history, wartime air power analysis, and comparative fighter research. Type continue for the next segment. The Hawker Tempest represented another leap in British fighter design. With a broad, thin wing and excellent low-altitude performance, the Tempest excelled as a ground attack escort and a V-1 interceptor. During the AFDU trials, test pilots documented its remarkable stability at high speed and its strong engine response during low-altitude sprints. These qualities proved crucial as the Luftwaffe deployed faster aircraft late in the war, including jet-powered threats. The Tempest delivered raw speed close to ground level and provided the RAF with a fighter capable of both dogfighting and pursuit operations. The trials allowed engineers to understand how its real performance compared to the claims made in squadron handbooks and earlier wind tunnel predictions. Alongside these British designs stood the American-built P-51 Mustang, which had earned a reputation for long-range escort duty deep into German territory. While the Mustang was not always the absolute fastest at low level, its outstanding efficiency, high-altitude speed, and aerodynamic refinement made it indispensable to the Allied strategic bombing campaign. The AFDU tests revealed how the Merlin-powered P-51 handled during sustained high-speed runs, and how its theoretical maximums compared to what pilots could consistently achieve in real service conditions. The trials confirmed the Mustang as a balanced, effective fighter with superb long-distance capability and reliable high-altitude performance. In early 1944, as America joined the war in full force and the Allied advance placed immense pressure, the Luftwaffe, the Royal Air Force, gained access to a series of rare opportunities. A number of German fighters made forced landings in Britain after combat damage or fuel loss, and others were recovered from frontline battlefields and shipped to England for detailed examination. These aircraft included late-war Messerschmitt Bf 109 variants and advanced Focke-Wulf FW 190 models, machines that were critical to German air defense. The Air Fighting Development Unit recognized that understanding these fighters was vital for tactical intelligence. The RAF wanted to know the true operational speed, climb power, and aerodynamic behavior of aircraft that pilots fought on a daily basis. At RAF Boscombe Down, engineers and test pilots faced significant challenges when working with captured Axis fighters. Maintenance was difficult because German aircraft systems were designed around specialized components, fuel mixtures, and engineering methods. Ground crews had to improvise repairs and create substitute parts using British materials. Test pilots who flew these machines needed extensive safety briefings because many controls, flight habits, and emergency procedures differed greatly from Allied designs. Even so, the RAF persisted because the information gained had immediate wartime value. Understanding the real performance of these German fighters allowed British commanders to plan air tactics more effectively and to anticipate enemy capabilities with confidence. The Focke-Wulf FW 190 was of particular interest. In combat reports, it had shown excellent roll rate, strong acceleration, and frightening low-altitude speed. When the AFDU tested a captured FW 190, the data confirmed that it was a formidable opponent below medium altitude. Yet the trials also revealed aerodynamic limitations that frontline pilots could exploit. This blend of strengths and weaknesses helped refine RAF dogfighting tactics and improved the training of new pilots. The Messerschmitt Bf 109G and later refinements also underwent evaluation. Although the 109 remained a dangerous and agile fighter, the AFDU discovered that its engine struggled to maintain consistent power under prolonged high-speed stress. Learning these details allowed British squadrons to capitalize on performance gaps and better understand enemy climb behavior. These captured aircraft trials were an important part of wartime intelligence gathering. By comparing German fighter performance directly against the Spitfire, Tempest, and Mustang under identical conditions, the RAF built a clearer picture of the true air balance in Europe. In October 1944, as Allied air forces intensified their pressure across occupied Europe and as jet aircraft first appeared in combat, the Royal Air Force understood that the margin for error in air strategy had narrowed. Before the United States and Britain committed fully to the final push toward Germany, the Air Fighting Development Unit compiled its complete high-speed trial data and produced findings that reshaped wartime aerial planning. The RAF compared every fighter tested at Boscombe Down using the same protocols, identical courses, and standardized fuel loads. This created one of the most reliable performance records in aviation history, a reference still used today by military aviation researchers studying World War II technology. The results revealed a hierarchy of speed and climb power that directly influenced how Allied air commanders deployed their fighters during the last months of the war. The Spitfire Mk XIV emerged as one of the fastest Allied piston engine fighters at medium and high altitudes. Its Griffon engine delivered exceptional high-altitude power that allowed it to intercept enemy aircraft with remarkable effectiveness. The test data confirmed that the Spitfire possessed outstanding acceleration during high-speed pursuit, making it ideal for countering fast German fighters. The Hawker Tempest proved to be the strongest low-altitude performer, achieving impressive top speeds close to ground level. This made the Tempest vital for intercepting V-1 flying bombs and for engaging low-flying German aircraft attempting to evade Allied control of the skies. The P-51 Mustang demonstrated consistent high-altitude speed and excellent long-range efficiency. The AFDU findings validated its role as a primary escort fighter, capable of sustaining high-speed cruise while protecting bombers over deep penetration missions. The AFDU high-speed trials marked a turning point in the scientific evaluation of combat aircraft. As jet fighters such as the German Me 262 appeared on the battlefield, the RAF recognized the importance of accurate performance testing for future air strategy. The legacy of the 1944 trials influenced post-war research, aircraft development, and the broader field of aviation engineering. The meticulous records created at Boscombe Down remain an essential resource for historians, pilots, and engineers who study World War II air combat, fighter performance analysis, technical aviation history, and the evolution of aerial warfare.